This is part 2 of our lesson on 2.3. Deductive reasoning uses facts and definitions, accepted properties and laws of logic to form a logical argument. This is different from inductive reasoning, which use specific examples and patterns to form a conjecture. In this section, we're going to look at 2 laws of logic that use deductive reasoning. The first law of logic is the law of detachment. Here's what it says. If the hypothesis of a true conditional statement is true, then the conclusion is also true. Think about that for a second. If the hypothesis of a true conditional statement is true, then the conclusion must be true also. Remember where we got into our trouble with our contract. If the hypothesis is true and this needs to be true also, then that has to be true also. The only way you can get the true conditional when your hypothesis is true is to have a true conclusion. Notice how when we didn't have a true conclusion, that changed everything. So that's where that law of detachment comes from. So here's an example. If today is Friday, then tomorrow is Saturday. I think we all know that that's true. Now let's say that we also know that today is Friday. What must be true? Well, it must be true that tomorrow is Saturday. If you have a true conditional and a true hypothesis, then this conclusion must be true as well. Now, that was a simple example. It didn't have a lot to do with math, but this one does. Let's find a solution using the law of detachment. If 2 segments have the same length, then they are congruent. That's the definition of congruence. That's true. Now, also, let's notice that it has been proven that segment BC has the same length as segment XY. That's how you read this. This distance and this distance are equal. Their lengths are the same. So we're talking about 2 segments that have the same length. So what do we know about those 2 segments? We know that they're congruent. That's the law of detachment. So here is your answer. We know the 2 segments are congruent. And if you just write that, that would be acceptable. But we can also be specific. Which 2 segments are congruent? Those 2. If we know these segments have the same length, then we know they're congruent. That's the law of detachment. Here's another example. This one doesn't have to do with math. Every Friday and Saturday night, Mary goes to the movies. Let's pretend that's true. Also, they're telling you that today is Friday. So if today is Friday and that's true also, what do you know? We know Mary's going to go to the movies. So that's the law of detachment. You have to have a true conditional. And the other information that they give you at the bottom here must also prove that the hypothesis is true. We know when there's a true hypothesis and a true conditional that the conclusion is also true. Be careful on this one. The law of detachment cannot always be applied. Every Friday and Saturday night, Mary goes to the movies. That's the same true conditional that we just had. We're assuming it's true anyways. But notice how today is Tuesday. What can you conclude? Well, this information does not prove that the hypothesis is true. Does that mean she's not going to go to the movies? No. Does it mean she is going to go to the movies? No. We don't know what to happen, what's going to happen. There is no conclusion to be made. Maybe she goes, maybe she doesn't. You don't know enough. All we know is she definitely goes every Friday and Saturday. We don't know anything about Tuesday. Maybe she goes, maybe she doesn't. So there's no conclusion that could be made here. And the reason is this statement right here does not prove that the hypothesis is true. Anytime that happens, you can't use the law of detachment. There will be no conclusion.